I have some epical news for you. It's Passover now, commemorating a separation between Jews and Egyptians. Well, we've gotten back together. I'm Joel Orr. I'm co-founder and visionary emeritus of Scion Research. I'm also CTO of a startup called Izosa, and I am an Israeli Jew. One of my partners, Sharif Al-Greatly, is an architect and inventor with more than 40 patents to his name, and he is also an Egyptian Muslim. So you can see that we're already operating at a breakthrough level here. This presentation gives an overview of his most recent patent, whose official name is a graphical data mapping technique, and it constitutes a breakthrough in extracting information from 2D and 3D models and has broad application in architecture, engineering, and modeling. Sharif noticed that the information that he, like most architects, is able to extract from a 2D drawing or a 3D model just by looking at it is more than any current software provides. For example, in extracting information from a floor plan to produce a structural model, this is typically a manual process for a professional. This made him curious. What was he doing to discern these additional pieces of information? So he chunked down his observation process and his eye movements to find out what he was doing to obtain this additional information. And once he had modeled his observation process, he came up with a way to express it algorithmically. So it's a form of spatial decomposition that uses a semantically meaningful naming technique to yield information that is useful with relatively little computation. And the software based on this approach assigns names to features based on their discovered attributes. The approach allows you to select a grid element that is appropriate to the problem at hand: square, rectangular, hexagonal, etc. Grid elements can overlap, giving enormous flexibility in the sorts of shapes you can look at. And it works in 3 dimensions as well as 2. And using cubes, polyhedra, various shapes, and so on. This way of looking at things also recognizes directionality. And, for example, it can determine the direction a given element is facing. So, the innovation is being put into action in a number of ways. One manifestation recognizes architectural objects such as walls, doors, windows, roofs, etc. within SketchUp files and inserts them as appropriate families into Revit. Now, if you're familiar with SketchUp, then you know that this is far more than a translation, because, in fact, SketchUp only provides you with polygons. And so it's an object recognition process that we go through. And it enables us to perform this process. Now, here is a second application of the data, which we call spec-driven design. It enables you to enter a site boundary, to put in objects, to put in interesting spaces and information that describes them, and then to insert the constraints that are of interest to you, the adjacencies, the views of the spaces, perhaps building code information, and then the software creates a solution and offers the ability to export the model to Revit and also to place the openings that are appropriate. We place those automatically. Of course, this can all be edited. And then we can show additional designs that might perhaps have lower overall cost. So, this is 2 of the applications that we are working on. We are also looking at finding shapes within point cloud data, and that's a little bit down the road. If you're interested in this, please approach me or Sharif anytime during CoFest. Thank you.